Hello children, now chapter 10 wave optics. In that we'll see the various theories about the nature of light. So before the previous chapter we have studied about the ray optics, which is nothing but the phenomenon which contains reflection, refraction, like a rectilinear propagation of light. So which theory which given that we can call it as a corpusculus theory, that Newton proposed the light consists of the tiny particles which are called corpuscles, which are shot out at high speed by luminous objects. So that theory explained about the reflection, refraction, which we have studied previously about rectilinear propagation of light and all. Now in this chapter we can call it as a wave theory of light, and duly this given by a more theory which is studied by Christian Huygens, the light which travels in the form of longitudinal wave, he said, and as like a sound propagation of light, right? See, this theory which explained about the reflection, refraction, as well as interference of light, diffraction, polarization of the light, like all these phenomena which are explained here, and electromagnetic wave nature. What is electromagnetic wave nature? We have studied in chapter 8 itself. That is nothing but the light which propagates as electric and as well as the magnetic field oscillations, right? These are called electromagnetic waves, and these waves are also transverse in nature, we know that. The next one is Planck's quantum nature of the light. So what is quantum nature? See, according to Max Planck, he said that light which travels in the form of small pockets of energy, which we can call it as a photon. See, this theory only helps to use to explain the photoelectric effect. So we see this phenomenon like interference, diffraction and polarization, how light behave as a wave while in photoelectric effects, and also it behaves as a particle. And also we can see and discuss about de Broglie's wave nature of light, and light has a dual nature. That and all we will see later, right? Next we can see that what is wavefront. About this wave nature of theory, in this chapter elaborately we can study about the the form of light, which how it travels as like reflection, refraction, interference, diffraction, like a different phenomenon. To explain all those phenomenon, how the light wave it started, or a general principle is valid for the wave or rays, we have to see first. So what is wavefront? The wavefront we can define as the continuous locus of all such particles in the medium, that is the point of disturbance due to the propagation of light, right? Now the line which is perpendicular to the wavefront, we can call it as theory. That is, the wavefront is a surface of a constant pace. The speed with which the wavefront moves outward from the source, which we can call it as a phase speed. We have the phase speed for the wavefront. The ray we said that is perpendicular to the wavefront in the direction of the propagation of wave, right? Now we'll see the different types of wavefront. See, this is a spherical wavefront which is from the point source, and it can travel in all the directions. By seeing the ray, you can understood that it is moving in all the directions from a point source. It is spherical in shape. The next one is which you are seeing, that is a cylindrical wavefront. See, this is the linear in shape, linear shape of source, and it is a fine rectangular slit, which is the wavefront is cylindrical in nature, right? And which you are seeing that the pink dots, which are all we can call it as that is a wavelets, which is the source, and the blue dots we can say that wave front, the wavefront which are come from that. And this diagram represents the plane wavefront. See, as a cylindrical and a spherical wavefront advances, its curvature decreases progressively. So a small portion, such a wavefront at a large distance from the source, will be a plane wavefront, right? So these are all the different types which you have seen, and we can say also the wavefront which are parallel to that parallel rays, converging rays of wavefront, diverging rays of wavefront, like a different wave which we can see, and all those things which is based on the principle of Huygen's principle. What is Huygen's principle? See, it is basis on the theory of wave theory of light. See, according to that, what we said, each point on wavefront is a source of the secondary wave, the new wave, right? So we can see that. See, this is the source which is from the you can consider a spherical or a plane source of position that we can see S is the source. And according to the Huygen's principle, we are seeing that all the wavelets are together, and it gives a source of the secondary disturbance, right, and which travels with the speed of light, we can say. See, we want to find a new wavefront. After some time, we can draw the radii for the spheres that you can see now. That point which we can call it as the tangential surface which you are seeing right now. This tangential surface which gives the new wavefront after some time, right? See, actually there is no backward wavefront is possible. See, there cannot be a backward wavefront of energy which during the propagation of a wave, because it is found that the amplitude of the secondary wavelet is proportional to the next one, so that it is not possible to the backward type, right? In fact, the effects of the secondary wavelet can cancel out at all points except those lying on the forward envelope. So we can agree with that the backward wavefront cannot be exist and possible, right? And the points which you are seeing, that each point on a wavefront as a new source of disturbance of light, and the new wavefront at any time later it obtained by taking the forward envelope of the secondary wavelet at the time. Now the next one is laws of reflection at a plane surface.